Hello, my name is Darren Cooper. I'm president at Rentechnic Group. I'm going to give you a short presentation today covering the solutions that we are providing in partnership with Centrica Business Solutions. So without further ado, I'm going to jump into this. I'm going to give you a little bit of background. I'm going to give you some information on our hardware software solutions and follow up with a few case study examples at the back end. Hopefully enough information to whet your appetite and get you coming back for a little bit more detail. So just a little bit of background on Rentechnic. We are a mechanical electrical consultant. We're based in Canada with offices in the UK, and we're serving a fairly global client base with our services. These typically are now focused on operational and energy efficiency rather than traditional design work, although we are technically still a mechanical electrical engineering consultant. We've been partnered with Panoramic Power and Centrica Business Solutions now since about 2015. In the work that we do, data acquisition is always really important, and especially real-time data acquisition. And Panoramic Power, that I'm going to give you some more information on here, is really a very, very powerful tool for that piece. And the partnership between ourselves and Panoramic provides our clients with a really good turnkey sort of solution. Not only are you getting the technology and the software, but you're also getting it properly set up, properly configured, either for your own utilization or for us to continue to help you on what we call your journey or your adventure to operational and energy excellence. So this platform is allowing us to do a lot of those insights and to bring real-time visibility to the operation. So what is Panoramic Power? Well, Panoramic Power is a completely unique technology. It consists of a number of pieces of hardware, these current transformers. And what makes this completely unique is the fact that they are completely wireless, self-powering, so there's no battery involved, no need to ever do service. Basically, once the system is installed, it becomes completely maintenance-free. So this literally is a solution that is installable. If necessary, it can be moved, it's portable, and no other need for junction boxes or conduit or any of those pieces. So the installation time is super quick. When it comes to this actual deployment piece, as I said, it's literally a snap to put in. So installing the hardware, snapping that around the wires. Once that's installed, these communicate within that radio frequency range to the bridge unit. This is essentially the gateway unit to the cloud. Once you're fully set up within the software, with your electrical hierarchy built and all of your devices in there, you can then start to use the platform to do those real-time analytics. There's also alerting and reporting features. So that is where you're ultimately now at the point where you're starting to create operational improvement and energy savings. Getting into a little bit more detail on the specifics of the hardware. For current only measurement, so in this scenario, we're measuring amperage only, and we put a plug number in for the voltage and the power factor. We have three devices in this category: the PAN 10, 0 to 63 amps, the PAN 12, 0 to 225, and the PAN 14, which is essentially a radio frequency transmitter that will convert any size split core CT into a wireless device. If you're looking to get into a little bit more detail from a data collection standpoint, we do have the full power meter. This is a full RMS meter, the PAN 42. So on a three-phase system with three reference voltages and three CTs, this will also give you real-time voltage, amperage, and power factor. And that can also be applied to the downstream current-only measurement in the 10s, 12s, and 14s. So all of these devices are self-powering with that radio frequency transmitter built in, all communicating to the gateway unit, which is the communication bridge here. Each of the communication bridges will manage up to 250 of these devices, assuming that, of course, they're within that communication range. From inside a piece of equipment, electrical panel, etc., we're typically seeing that range is something in the range of 15 to maybe 50 feet. It depends a little bit on the particular environment that it's being installed in. The communication bridge itself, there are two versions of this. There's the standard bridge, which is using a Wi-Fi or LAN connection to essentially take that collected data and push it into the cloud-based database where the software and analytics reside. The second option is to go to the enhanced version of the bridge. So this enhanced version has a built-in LTE modem. So with a cellular SIM card and a data package, this information will be pushed to the cloud in real time through the cellular network instead of through the internal network. One of the big questions we also get asked is, what about data? Does it have to go to the cloud? How else can we get access to the data? Well, first of all, the cloud-based platform and the analytics and alerting is extremely powerful. And once you start using it, there isn't really a big need to do anything else with the data. But having said that, if you absolutely have to, three ways of getting it. You can do a CSV export from the platform itself and use that data in Excel. There's also an API function that allows raw data to be exported from the cloud database into another platform. And also, lastly, through Modbus TCP, the first 36 registries of those 250 within the communication bridge can be exported locally into another platform without needing to go to the cloud. The communication bridge does need a power supply, so you need a standard plug in order to plug it in and power it up. And in addition to that, each communication bridge has two pulse input port capabilities. So what this allows for is the utilization of third-party data into the platform. So not only is it an electrical sub-metering solution, but we now also have the ability to bring in sub-metered data, for example, gas, water, compressed airflow, pressure, etc. So those other systems within a facility can also have that data brought in to them. In addition to all of that, we can also potentially incorporate the utility data as well. So if you have a smart meter with a demarcation point from your utility, that information can also be brought into the platform. So you could see facility level gas, water, and electricity within the platform. Now, in a lot of instances, there are existing meters, particularly gas and water meters, where those are not smart meters. They're just a traditional mechanical meter. So one of the added components that we also have is the ability to attach a strap-on sensor to those existing meters, and essentially that sensor will read the mechanical rotation of the meter and convert that into a pulse that can be expanded and brought into the software platform itself. Just touching very briefly on Power Radar, which is the software platform now. So in the cloud, you have all of your data storage. That export is happening on a 1-minute interval. So that's the lowest granularity that you can see in the software. The devices are actually reading every 10 seconds, and then that's averaged to that 1 minute. But essentially, database in the cloud with granularity down to 1 minute. We also have a rolling data storage window in the cloud, which is 5 years. So essentially, year 6 would overwrite year 1, year 7 would overwrite year 2, and you have that constant rolling, basically 5 years of historical data. So within the platform itself, I'm going to show you a couple of screenshots here, just to kind of whet your appetite for some of the things that are there. But there are a lot of analytical functions you can compare right down to individual device levels or groups of devices within the system. And again, one of the important pieces is building your hierarchy correctly so that all of these features work. There's also alerting and alarming features that can be set around things like usage outside of certain schedules, or where you've got an under or over amperage, and then some automatic reporting. So just very briefly touching on this, there's a lot to show in this platform, but just to give a little bit of idea, on this left-hand side, you can see there's a hierarchy of all the various pieces, and I happen to just have picked 4 motors associated with some extruder equipment, and this can be displayed in real time, or the historical data, as I just mentioned. So here I just have a 1-day plot of these particular pieces of equipment. Again, this could actually be in real time, so a partial day visible. We can look at this in a 6-hour, 1-day, weekly, monthly, and yearly. You can overlay whatever information you want from any multitude of the pieces of equipment. There's also the ability to compare similar pieces of equipment at different different facilities within the platform. Again, in real time, just clicking and overlaying that. One of the other features in the software is we can incorporate a cost for the utility. So when you've incorporated cost, you're able to see, again, the operational cost of the equipment, either hourly, daily. This particular example, I'm still looking at those same 4 motors, and this is weekly. So this is the operating cost per day of each of those 4 motors. So this can be a very powerful tool often as well, just where people aren't familiar with what a kilowatt or kilowatt hour is. So if you can talk about dollars and cents, pounds and pence, you're going to be able to see a higher engagement basically from people who understand money. They don't necessarily understand power and electricity. There are a number of other tools within the platform, one of which is a heat map. So this is a pretty easy means of looking at visually what's happening. This can be done at system level, subsystem level, or right the way down to individual devices. And essentially this gives you a midnight to midnight, left to right, and then the last 4-week period of energy intensity. So this is a lighting system, and you can clearly see it sort of comes on at 8 in the morning, goes off at 5 days a week when the space is occupied. Within the platform as well is an energy flow. This is a really useful tool. So again, a breakdown from your total incoming by your categories and subcategories, and then down into the individual devices. And the benefit of this is that you can often see at a glance the higher use equipment, so that can focus your efforts from a retrofit sort of opportunity standpoint, as well as helping you maybe move to a more performance-based rather than passage of time service and maintenance activity. So higher use equipment gets more attention, less use equipment doesn't get as much, compared to the traditional kind of way of, at a certain point, all the equipment gets the same amount of maintenance done with it. And as I say, if you'd like to see this in real time, in action, feel free to reach out. We'd be happy to do a live demonstration on it. So just to wrap this up here, I've got a few examples coming up from some real opportunities that we've discovered with some of our clients, just a few different ones, again, to give you a sort of an idea. So one of the things that real-time data gives you is an understanding of how your equipment operates and where you're using energy. And a simple example of that is a process cooling system. So a great big chiller, a bunch of small pumps. There's often a misconception about where the system is actually using the most energy. So in this particular example, you can see that the pumps in particular are a significant use of energy or user of energy within this particular system. So that's an area to focus on. In this particular system, a lot of these pumps were manually throttled to control the required flow. So we built a very good business case around replacing the manual throttling with variable frequency drives to slow down the pump in order to control the flow. An amazing project, some huge energy savings, just a little over a year of simple payback, improvement to the overall operation of the system, because the VFD was able to control and maintain the temperature better than the manual throttling that was previously done. So an example of a very successful project. Another example, this was looking at a compressed air system. So the top blue line here is the overall operation of all of the production equipment. This lower line is the compressed air system. And what we discovered was that even when production is greatly reduced, the compressed air system continues to operate at the same rate or capacity. And interestingly enough, this was almost 10% of the total plant operational cost in the compressed air system. So having identified this piece, the maintenance folks went out and had a look around, and they discovered that there was an issue with a valve in the system that was stuck. And this stuck valve was causing the compressed air system basically to run constantly all the time. With a little bit of focused service and maintenance and the real-time data, we were able to clearly demonstrate that the saving had been created. We were able to validate what that was and what that related to from an annual consumption point. So in this particular case, a $36,000 saving in the operation of that compressed air system. Also looking at the functionality of equipment. So this is vacuum pumps, and you can clearly see one pump, the blue one here, cycles off and on correctly. Pump number 3 is running continually. So this is having an impact on production. as well as obviously stressing that particular asset, maybe shortening the life expectancy and certainly using more energy than it should. Coming up here, one last example. So this was taking a VFD on an existing gooseneck conveyor and just adjusting the operation of that conveyor with the existing VFD. So some visualization of the data and what's happening produced an overall reduction in the conveyor operation. And then to add to that, we also built in a whole series of amperage alerts on the conveyor system. So if the belts became overloaded with material, the operators would get an alert that the motor was working too hard, that amperage change outside of the normal operating range. And that led to the ability to regularly clear blockages that were occurring that historically would have stopped production. So huge operational saving by not getting to the point of shutdown in that particular system and operation. And as I said, I could give a multitude of examples here of different opportunities, both in operational efficiency, energy efficiency, the real-time data allowing a proper business case to be built, get funds allocated for that, whether it's capital funds or focusing service and maintenance activities, all of which also with that data allows for a true ROI to be developed to show the benefit of all the efforts that have been put in, and therefore continue on this journey to energy excellence. So hopefully that very quick overview of both the panoramic power technology, that actionable insights at your fingertips will have encouraged you to commence your adventure to your operational and energy excellence. And with that, I will end and we can turn this over to a Q&A session. Thanks for your time.